Okay, this is continuation of yesterday. So if you guys remember yesterday we did electric furnaces. We did calculation for electric furnaces, baseboard heaters. And the last component I would like to do, which also going to be in our test, not like to make you pay more attention, but it's so important, is to size branch circuits for AC systems, AC units, air conditioning. The special thing about AC units, guys, like we talked yesterday, every time you have compressors, hermetic compressor motors, coupled together, built together to make a system, they function differently, and the code treats them differently and refers you, even though they have motors in them, they refer you to an Article 440 because of their characteristics, or they behave differently and they have different characteristics enough to distinguish them from standalone motors. What's in it for you? Every time you have a chiller, an air conditioning, a refrigerating system, anything that has, basically anything that has a refrigeration cycle in it, you have to adhere to a certain rules and regulations. Cool? So what I have for you guys is the following. I have a panel. Again, we're doing dwelling, so I kept the NAM cable is the wiring methods, very important. I have a 200 amp panel, 24120, feeding other things, and among them is two air conditioning. One of them is called A, the other one is called B. And the first one has a rated load current right on the nameplate. They stamp it with a rated load current of 17.8. The second one is 24.2. The voltage for both of them is 240. And it says, and we're going to be using circuit breakers because it says use circuit breaker. Before I go ahead and size, and I need to size the following. I need to size the branch circuit conductors. And moving on, Adam, if you guys, here's where I got aggravated. If you guys, we graduate from here and you say, I'm sizing the conductors, Chad. Conductors are an average Joe outside the electrical industry talk. If you're in the electrical industry, you don't size conductors, you size branch circuit conductors. So because conductors can be feeder conductors, can be service conductors, or can be branch circuit conductors. So when you guys want to jump for interviews, or when you talk to your colleagues, always size, I'm sizing the branch circuit conductors. There are rules and regulations for this. Feeder conductors and service conductors, cool? So what we're sizing here is not the feeder, we're sizing the branch circuit conductors. So learn the terminology that we use in the code, guys. It helps you a lot. Most of the people get confused because they don't use the right terminology. I'm sizing the wires. What type of wires is that? You know what I mean? I'm sizing the branch circuit conductors. And then after you size the branch circuit conductor, you have to refer to what type of wiring methods are you using. You have to, because based on the wiring methods, it will force you to size them differently. If you're using an NM cable, you're forced to go to 60. If you use an MC cable, you can go to 75. So it's a wiring method is a big deal. Okay, we're going to size the branch circuit conductors, the overconduction device, that disconnect. Everybody knows why we have the disconnect, so we can disconnect the equipment to work on it. And the equipment grounded conductor for both of them. Cool? For both of them, and the equipment, there is also an equipment grounded conductor that comes with this equipment. One thing missing, Adam, from this picture. Anybody knows what's missing from this picture? The controller. Remember what we did before? We always looked at the controller. Why don't I size the controller? Because 99.9% of the time when you have an AC system, a chiller, the controller will be provided by the manufacturer. So we did not mess with the controller, and it's really going to be similar to sizing a controller for a motor. Similar to sizing a controller for a motor, based on the locked rotor current and the voltage and the horsepower. Okay, any comments, guys? Any questions about these? Everybody knows what we're doing? We're using called Hacker, H-A-C-R. Hacker circuit breakers are circuit breakers tested and listed to work properly with HVAC equipment, as in heating and cooling equipment, as in cooling equipment in particular. They test them to work with a chiller or an AC unit. And my understanding, almost all the circuits, a lot of circuit breakers are tested now. Okay, comments, questions. The article that talks about this topic is 440. That's your article. All the references I'm going to be writing it. My expectation, guys, if you were to understand this fully, is to go to the code and highlight them directly into the code. Cool. All right, so let's go ahead and size the first thing. The first thing we need to size is the branch circuits. So for branch circuits, I need to size my branch circuits. Let's size my branch circuits here. For branch circuits, what I would like to do, guys, is first I need to give you that reference. Your reference is 440.32. Now, if Derek said, "Why did you do this the way you did it, Chad?" Why are you doing it this way? Because 440.32 tells me to do it this way. Okay. 1.25 times that magic 1.25 times the 17.8 amps, and that will get you a healthy 22.3 amps. And then you take your 22.3 amps, take them to table 310.15 B16 under 60-degree column. And anybody knows why 60-degree column? Because we're using NM cable. And that will get you number 10/2 AWG THHN NMB cable. THHN NMB cable. The installation is THHN, the cable is NMB. All these two conductors, number 10, THHN, each one of them cabled together, not by me, by the manufacturer. Okay, that's a piece of cake. Can you guys see that magic 1.25? If you don't know how to size a feeder for any type of load, if you guess, you multiply the amp by 1.25, you are right at least 90% of the times. Does that make sense? Okay. Number 2. So that's straightforward. We did it yesterday too. Overcurrent protection device. Circuit breaker. For overcurrent protection device, your reference is going to be 440.22a. That's my reference. 440.22a. It's so important to know the reference. It says you take 1.75. Why 1.75, not 1.5? Because if you guys go to you go to 440.22, it tells you use 1.75. Multiply it by 17.8, get you a healthy 31.15 amp. And then you take your 31.2 amps. Let's do 31.2 amps here. 31.2 amps. Take this baby to 240.6. Size yourself. You have to go down. If it's not a standard, do not, shall not, will not go up. Why don't you go up? Because it doesn't say go up. It doesn't allow you to. If you guys go read 440.22a, which I should, it doesn't say go up. So if you can't go up, I need a 31.2 amp fuse or circuit breaker. They don't make them. You have two options. I always say three options. Three options. Let's give you the three options. Number 1, you can custom design a fuse or a circuit breaker, 31.2 amps, and they will be more than happy to do that for you for an arm and a leg. Number 2, you get mad, and I always say you go to the bar and start drinking and get mad at the world because they don't make a 31.2 amp. That's another option too. The third option is to go down. So which option do you guys want to do? The second option is the best. You're not 21 yet, are you? So you can't. So the third option, which is going down to 30 amp. How many poles? I have 2 poles. Always the poles are a big deal, guys. Circuit breaker, and the type is a hacker. Hacker. They call them hacker. What does a hacker means? Heating, air conditioning rated. Heating and air conditioning rated means it's made, tested to work with air conditioning. And again, my understanding is many of the circuit breakers that we use right now are hackers, so you don't have to worry too much about it. Any comments, any questions? So 30 amp, 2-pole. Why 2-pole? We have 240. Any comments, guys? Any questions? Move? Yes, no, slow. Okay. Next, disconnect. Your disconnect article, guys, your disconnect reference is 440.12a1. This is your reference. For disconnects, here's what you do. You take 1.15, you multiply exactly like motors, 17.8. That will get you a healthy 20.5 amp. And then you take your 20.5 amp and you take it to D Walt 3-12, and it will tell you, do me a favor, use a 30 amp 2-pole disconnect. 30 amp 2-pole disconnect. Why 30 amp? Because the next standard after 20.5 is disconnects, guys, comes as 30, 60, 100, and after that, for the most part, multiple hundreds. Unlike circuit breakers, where they can come different. So now I can go size myself a big fat board like this, you know, right next to the equipment, and that will take care of me. Okay, the last thing we have on this particular one is number 4. Number 4 is equipment grounding conductor. What you do for the equipment grounding conductor is 30. You take your 30 amps. We did that yesterday. Table 2, 50.1, 2, and 2. 250.1, 2, 2. And that will get you a healthy one conductor number 10 AWG THHN in the same cable, THHN in an MB cable. So we really don't size it, so to speak. It will come part of my NMB cable, but I would like you to go through the sizing. See how easy that is? Now you can't get easier than that. Okay. Now I want to go back one step here, and I want to get you to write. Can you guys go to step number 1? And do you see that value here? This value that you calculated here? Can you write next to it? This is called the minimum circuit ampacity. This value that you calculated is called minimum circuit ampacity, and the manufacturers will actually plant or print this value on the nameplate, so you do not need to do the math. One more time. This calculation, see that math that we did here? This will be done by the manufacturer for you, and they will print this on the nameplate, and they call it minimum circuit ampacity. So, Adam, you shall not do the math. When you see minimum circuit ampacity, what do? Grab that number, like I did here, grab that number, and size the conductor. Can I have thumbs up, Chad? We understand that one? Okay. Next, the overcurrent protection device. That guy here. That guy here, guys, is also right next to it, please. This is maximum overcurrent protection. Maximum over MOP, maximum overcurrent protection. Maximum overcurrent protection, MOP. This is also done by the manufacturer for you. So this number will be on the nameplate, says MOP 30 amp, and it will also say next to it circuit breaker or fuse, then you have to provide a circuit breaker or fuse. If it says fuse, you provide a fuse. Circuit breaker, you provide a circuit breaker. If it doesn't say, if it says fuse or circuit breaker, it's up to you. Can I have thumbs up, Chad? We fully understand that these two values typically on the nameplate, and you will not do the math for them. Okay? Why? They're special equipment. So this math that you have done here, guys, that came up with this value right here is done by the manufacturer for you. So why, Chad, did you make us do it then? I want you to know how to do it. But typically, when you have an AC unit, always look at the MOP and the minimum circuit impedance. Okay, now the disconnect, you have to size the disconnect. It's not on the nameplate. Okay, let's go to example number 2. Example number 2, guys, the second air conditioning that we have in this system. Let's go do the second AC that we have in my system here. Okay, second AC that we have. Anybody can guess what we're going to do for the brine circuit? The brine circuit, the same thing, guys. 1.25 multiplied by, the second one is a 24.2. It's a 24.2 rated load amp. So you multiply by 24.2, get you at 30.3 amps. And 30.3 amps. If you go to 310 table, 310.15 B16 under 60-degree columns. Okay, 30.3. The code allows you guys, if it's 0.3 or less, you can get rid of it. So really, for all practical reasons, since the amps here is very small, this becomes 30 amps. Does that make sense? Because it's less than 0.5. If it's 0.5 or more, you have to go up. Less than 0.5, go down. So this becomes, for all practical reasons, 30 amps, right? So for this, I continue to use number 10 to AWGTHHNNMB cable. NMB cable. Did you guys see why I use 30? Because 0.3, the code says if it's less than 0.5, you can drop it when you size. Had this been 0.5, it becomes 31. You have to go to number 8. Done. Okay. Overcurrent protection device. Then overcurrent protection device. CB, circuit breaker. Same calculation, 1.75 multiplied by 24.2. And that will give me 42.4 amps. 42.4 amps. I shall go to 42.4 amps. Take it to 240.6. And then you will end up with 40 amp 2-pole circuit breaker. Now I have an overcurrent protection device 40 landing on the 30 amps. These are HVAC equipment and motors and so forth. That's okay in this case. Can I lower the 40 amps to 30 amps? Yeah. For circuit breakers, guys, you can go that when you what you're sizing is the maximum. Okay. Before I leave this, I want to bring to your attention, guys, that this value is called maximum overcurrent protection, and it will be on the nameplate. And this value will be called minimum circuit amplicity, and it will be on the nameplate. Can you guys highlight these? It will be on the nameplate, so you don't have to mess around with it. Okay? Disconnects. For disconnects, my friends, for my disconnects, I'm going to take 1.15, multiply it by my 24, at 24.2. That will get me a healthy 27.8 amps. And that will be at 27.8 amps. Take it to 2, oops, this is the wall. The wall 3-12. When you go there, it's going to get you same thing, 30 amps, 2 pole, and same thing, non-fused disconnect. Do I need a fuse in it? The one before is also non-fused. When it comes to disconnect, guys, it's always good to specify it's a non-fused disconnect on your plants, because typically they have a fuse. A disconnect can house a fuse. If you don't need a fuse, why don't we need a fuse? Because we size the circuit breaker to take care of the overcapacity device situation. Equipment ground conductor. For equipment ground conductor, guys, you're going to take number 40 amps. You're going to take it to table 250.122. And what would that give you? One conductor, number 10, AWG, N, THHN, or, well, it could be bare here. Really, it could be bare, or in NM cable, it will be bare. So let's say in NMB cable. An NMB cable. Number 2. Yeah. Any comments, guys? Any questions? Any comments? Any questions? So that's basically what you size board for the AC. So typically for the air conditioning system, guys, in practical, we'll end up only sizing, really, the only thing that you end up sizing is you end up sizing the last 2 steps, because the rest are given. You end up sizing a disconnect and the equivalent conductor, because the rest are calculation-wise given for you. When I say given, you just don't need, see that math here? That math here is already, will be done for you, and that math here will be done for you. So all what you have to do actually will be done all the way up to here. It will be, they pick the fuse and they pick the amp size of the conductor. They wouldn't pick the conductor size though. They pick the amp size of the conductor. You have to go pick up the actual conductor size in AWG. But this math, you have to do it, because you need to size the disconnect. And here there is no math. You just go to the table. Any comments, guys? Any questions about AC units? As we go to the commercial, instead of AC units, guys, we're going to call them condensers, and we're going to call them chillers. And we're going to start sizing the same thing for chillers and condensers. Any questions? Is that good enough, guys, to get you focused a little bit? Okay, that's all we have. Thank you.